Hello and welcome to this video where we're going to talk about probability, and in particular we're going to talk about tree diagrams. So I want you to think for a minute, what is the chance of, when you throw a coin, here we have $0.25, what is the chance of getting heads? Now I think that most of you will agree that that probability is going to be 50% and that the chance of getting tails is going to be 50%. Now in mathematics we prefer to not express it as a percentage, but directly as a number from 0 to 1, where 1 would be the same thing as 100% really is. So we can really also express this as a fraction. Now this would be a very simple example of a probability exercise. What is the chance of getting heads and what is the chance of getting tails? 1/2 and 1/2. Now if I'm going to take this coin and I'm going to throw it, this is what I can actually do. Well, there's two possible things that can happen. Either I get heads or I get tails. The chance of getting heads is going to be 1/2 and the chance of getting tails is going to be 1/2. Realize that these are all the possible outcomes there are, therefore there's no third branch coming out here, because all on these two branches have already covered all the possibilities. That's 100% of the possibilities, or if I'm thinking of numbers between 0 and 1, well, these two must add up to 1. Therefore I throw my coin and I get heads. What happens if I throw it again afterwards? If I throw it again afterwards, well, same thing applies. Either I get heads or I get tails. And interestingly, the probability of these things happening do not change. It's going to still be 1/2. And what if I had tails in my first throw? Well, again, the chance of it happening is going to be 1/2 and 1/2. This is what we call a tree diagram, because it has these little branches that spread out just like a tree does. So of course, if you think about it, I have 1/2 chance of getting heads, and once I get here, I have 1/2 chance of getting heads again. So these two options are going to add up to 1, and these two are going to add up to 1 because they are the possible options, all the possible options in my second throw if in the first throw I had heads, and these are all the possible options in my second throw if in the first throw I had tails. Now what happens if I want to calculate the chance of getting heads 2 times in a row? You can write it like this. Probability of getting heads, and think of this little symbol here as and. It's not exactly precise, but just to understand it. So probability of getting heads and getting heads again. Well, that can be calculated in the following way. The first chance of getting heads is going to be 1/2, so I've already gone through a chance of 1/2. Of that 1/2, the chance of getting heads again is going to be 1/2. So I can think of it in the following way. 1/2 to get heads in the first run, and then of this one I must get another half, so I multiply. And therefore the chance is 1/4. Similarly, I could calculate the chance of getting the tails 2 times, and that would also be 1/2 times 1/2, which would be 1/4. Tree diagrams are going to be probably our main tool to look at probabilistic situations. And there's a little bit of more of thinking to do about this that I would like to talk about. Let this just be a simple introduction. Let me now do the same thing with the dice. Well, if I have this dice, and I want to analyze the probability of getting a 5, well, two things can happen when I throw the dice. Either I get a 5, or I don't get a 5. Please note this notation here, we call it a complementary, which is simply the opposite. The chance of getting a 5, the chance of not getting a 5. And note that this is what simply is going to happen. The chance of getting a 5 is 1/6, while the chance of not getting a 5 is going to be 5/6. If I throw the dice again, well, same thing's going to happen. 1 out of 6, 5 out of 6, 1 out of 6, 5 out of 6. And note here that I can therefore calculate what is the chance of getting 2 5s in a row. The chance of getting 2 5s in a row is going to be 1 over 6 times 1 over 6. And if you look back at our video on the probability grid, you will realize that indeed that was a chance. That was a probability. When we had a 5 here, and we had a 5 here, there was just one place where these two met. Out of all the 36 different places that I had, there was just one place where I had a 5 and I had a 5. So in both methods, I can calculate the chance of getting 2 5s, whether it is by using a probability grid or by using a tree diagram. My recommendation in general is that you use tree diagrams a lot. They turn out to be the most useful tool that we are going to work with. Thank you for watching. Goodbye.